important application of the multiplication principle of counting is to count the number of ways that a set of n objects, called an n set, can be arranged in order. Each such ordering is called a permutation of the set. Example 1 showed that there are 3 factorial, which is equal to 6 permutations of a 3 set. In fact, if you understood that the tree diagram, you can probably guess how many permutations there are of an n set. Usually the elements of a set are distinguishable from one another, but we can adjust our counting when they are not, as we'll see in example 3. Now, when we have n factorial, one thing you need to remember, n factorial, if you have an 8 factorial, it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you count down and multiply all of those. So count the number of different 9-letter words. Don't worry about whether they're in the dictionary. They can be formed using the word letters in each word. Now, if we look at the word dragonfly, you should be able to see there are no repeating letters. So what that means is we'll have 9 factorial, which again means 9 times 8 times 7 times 6 times 5, all those. So there are 362,880 words. Including the word dragonfly. Now, a nice easy way you can put factorial in your calculator, we could press 9, press the math button, go over to probability, go down to number 4, there's 9 factorial. A nice easy way to do it instead of putting in 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Saves a lot of time. Now, if we look at the word butterfly, you should be able to see that we have the double T here. So what we're going to do, we're going to take 9 factorial divided by 2 factorial, because 2 or so 1 letter repeated twice. So what we're going to have then, so we'll have 9 factorial divided by 2 factorial. 181,440 different words. Now, if you look at the word bumblebee, you should see that I have a B here, a B here, and a B here. That I have also 3 different E's. So we'll take 9 factorial divided by 3 factorial and 3 factorial. The B repeats 3 times, and the E also repeats 3 times. So we'll take 9 factorial divided by parentheses 3 factorial. But 10,080 words. And there you have it. Those are different words, different 9-letter words you can do just by rearranging the letters. Now, distinguishable permutations. There are n factorial distinguishable permutations of an n set containing n distinguishable objects. So that's if none of the objects repeat. If an n set contains objects, n1 objects of the first kind, n2 objects of the second kind, with all of them equal to n, then the number of distinguishable permutations of the n set is n factorial divided by all those. That's if they repeat. Now, in many counting problems, we're interested in using n objects to fill r blanks in order, where r is less than n. These are called permutations of n objects taken r at a time. The procedure for counting them is the same, only this time we run out of blanks before we run out of objects. The first blank can be filled in n ways, the second in n minus 1, and so on until we come to the rth blank, which can be filled in n minus r minus 1 ways. By the multiplication principle, we can fill in all the r blanks in n times n minus 1 times n minus 2, all the way to n minus r plus 1 ways. This expression can be written in a more compact but less easily computed ways as n factorial over n minus r factorial. The number of permutations of n objects taken r at a time is denoted by NPR, permutation taken, n objects taken r at a time. Now, I realize there's that empty box there. That's how I had to put it in Microsoft Word in order to get the correct notation. So it would be n factorial over n minus r factorial. If r is greater than n, then the permutation will be 0. Notice, though, that if n is the same, we'll have n factorial over 0 factorial, which is really n factorial over 1, which is equal to n factorial, which you've already seen is the number of permutations of a complete set of n objects. That's why we define 0 factorial as 1. That's one big thing that we need to remember. This might be helpful also on the ACT or SAT to know that 0 factorial is actually equal to 1. So evaluate each expression without a calculator. So what we're going to do here, it's n is 6, r is 4. So we're going to have 6 factorial over 6 minus 4 factorial, which would really be 6 factorial over 2 factorial, which means 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. Now you should be able to see that the 2 times 1 goes away. So we're at 6 times 5 times 4 times 3, which is really 30 times 12. 30 times 12 will be 360 waves. So evaluate each, so it's going to be 360. Doing the same thing with b. This would be 11 factorial over 11 minus 3 factorial. Should be 11 factorial over 8 factorial, which means we'll have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now you should be able to see 8 times all those will cancel out here. So 11 times 10 times 9, which will give you 990. Now if we look at C, really we'll have n factorial over n minus 3 factorial. That will be n factorial times n minus 1 factorial times n minus 2. Actually, hold on. No factorials here. So it'll be n times n minus 1 times n minus 2 will be our answer there. So we're starting off with our first one, and then the next term will be 1 less than n. The following term, the third term, will be 2 less than our original object there. That's how we came up with that. Moving on to example 5, we're actually going to apply some permutations. Now, 16 actors answer a casting call to try for roles as dwarfs in a production of Snow White and 7 Dwarfs. In how many different ways can a director cast the 7 roles? So that means we have 16, but we're going to choose 7. Okay, 16 permutations, 7 there. So that means what we're going to do then, we're going to have 16 factorial over 16 minus 7 factorial, which would really be 16 factorial over 9 factorial. Now, there is a way, again, we can do this on our calculator. We can do 16 factorial divided by 9 factorial. You get an answer there of 576,000, or sorry, 576,576,00. So there's 57,657,600 different ways that the director can choose who is which dwarf. Now, there is another way you can use your calculator here. As you're looking through the math menu, If you go 16, you can see number 2 is NPR, which is what we're dealing with, and that's 7. That will also give us the same number, 57,657,600 different ways. Another way to use your calculator in this case. Now, from among 12 projects under consideration, the mayor must put together a prioritized list that is ordered of 6 projects to submit to the city council for funding. How many such lists can be formed? So that means I'll have 12 permutation 6, which means I'll have 12 factorial over 12 minus 6 factorial, which will really be 12 factorial over 6 factorial. Using your calculator, $665,280. Now again, to use your calculator using a different method, 12, put on NPR 6, you get the same number, 665,280.